Welcome back to Mr Gard's maths class. This lesson is going to be looking at two-step experiments. Now, as I've written, two-step experiments are used when there are two events. So, rather than the basic probability formula that we were using in the last lesson, where it was something like, what are the chances of flipping a head? We know that that's 50% or 0.5. What are the chances of flipping two heads? The way we're going to do this is we're going to use a two-step table. Now I've written down probability in brackets flipping 2h, so that just means two heads. We're going to use the same formula as before, where the top line, the numerator, is the number of outcomes where the event occurs. So how many times do we get a head and then another head, divided by the total number of outcomes. So how many different possibilities could we get? So we draw a table because for some of these, they can be quite difficult. So in the bottom left, I have a little two-way table. The top option is we either have a head or we have a tail with the first toss, and with the second toss, the same deal. We can either have a head or a tail. So now we go ahead and fill in the table. So all of the different options there are if toss 1 we get a head, and then toss 2 we get another head. Then over here we get a tail and then a head. And down here we have a head and a tail, and then a tail and a tail. They are the 4 different possibilities we can get by tossing 2 coins in a row. Now, because we are looking at flipping just 2 heads, this is the box that we are looking at. It's the only one where there are 2 heads. So, according to our red formula, which I suggest you write down if you don't have it easily accessible from the last lesson, write down the number of outcomes where the event occurs. So we get a head and a head just once, and the total number of different possibilities are 4. Okay, because a tail head and a head tail are 2 different results in this situation. So the probability of flipping 2 heads is 1/4 or 0.25. These tables generally will only work when you have a 2-step experiment. So if we were to incorporate a third toss into this method would not be suitable. So a 2-step experiment is for when there are just two different experiments or events. Another common one that you will see a little bit of is this dice scenario. So we have 2 dice. Imagine we're playing a game of Monopoly and you roll both dice. The number of results you can get range from 2 if you get 2 1s or 12, which are 2 6s. Now looking at this box or this square of results, you can see that the most common score that you can roll is a 7. And we can work out something like what is the probability of, we'll come up with a scenario of a score, we'll call it a score bigger than 7. So what is the probability of rolling a score bigger or larger than 7? So this is our two-way table. So this is dice 1, dice 2. So if you roll a 1 and a 1, you get a 2 and a 1, you get a 3, and so on. I think you might get the general idea. So the number of outcomes where the event occurs. So how many times do we roll a number bigger than 7? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different times. So there are 15 ways of rolling a score bigger than 7. And out of, there must be 6 by 6, which is 36. We must be able to simplify that by dividing by 3. So we get 5 on the top line, 12 on the bottom line. So the probability of rolling a score larger than 7 is 5/12. There are other little scenarios that you might have. It might be you roll a dice and you flip a coin. What are the chances of getting a tail and an even number? In that case, you would simply create a different looking table. It might be something like this. I'm just doing this very crudely. 1, 2, 3, 4, 5, and 6, and that might be heads and tail. So you get a 1 and a heads, 1 and a tail, 2 and a head, 2 and a tail. The key to these two-step experiments is drawing your table correctly. Once your table is drawn correctly, you'll be able to pull all of the data that you need to determine your probability. That's largely it from today's lesson. Remember, draw your tables up really nicely because that will therefore make it easier for you to work out your probabilities. Thank you for listening.